On the 5th day of Christmas, the mather gave to me one integral test. That's right, technically we are doing a summation. We're gonna go ahead and check whether a summation converges or diverges. And the way we're gonna do this is using an integral test. Now, an integral test is a powerful tool that many calculus students and above are gonna see, because whenever you have a series, which we don't know whether it diverges or converges, we can use the integral test to take the improper integral. And if the improper integral converges, then that series converges. And similarly, if the improper integral diverges, then the series will diverge. All right, let's go have some fun. So here's what we have in question. We have the series from 0 to infinity of n e to the negative n squared, and we're asking whether it converges or diverges. And again, we're gonna go ahead and use the integral test, because the integral test tells us that if the improper integral converges, meaning we find a value, then the series will converge. Not necessarily to that value, but it will converge. And if the improper integral diverges, then this series will also diverge. So we're gonna go ahead up and set up the integral from 0 to infinity of x e to the negative x squared with disrespect to x. And as you can see, this is basically the series from 0 to infinity, because those were our bounds for the series here. And then I just changed the variables to x to make it more familiar. Now, let's go ahead and solve this using a u substitution. So u will equal to our x squared, and our du will be 2x dx. We can go ahead and divide the 2x to the other side, and that gives us du over 2x is equal to our dx, and now we can go ahead and rewrite our integral. But not before we take care of our bounds, because now we're gonna go ahead and write it in terms of u. So when x is equal to 0, we have this is equal to 0, so u will equal 0. And when x is equal to infinity, which was the upper bound, well, u is infinity squared, also infinity. We're just gonna go ahead and approach it infinity. So now what we have is an improper integral that we have limit as b approaches infinity from 0 to b, and now we have x e to the negative u, and then our du was du over 2x. And I wanted to write this so that I can drive my point across, that the x's will cancel out here. So we still have the limit as b approaches infinity. And notice that in this case, I'm actually doing a improper integral by putting the limit, because I know that calculus 2 students, this is the way they're taught, and this is the way your calculus teacher will expect you to do it. So now the x's cancel out like I mentioned. The 2 that was on the denominator can go on the outside. I'll do that in a second. I'm just gonna put 1/2 e to the negative u du. So this is now gonna become the limit as b approaches infinity, and now we have negative 1/2 e to the negative u from 0 to b. Implementing the first fundamental theorem of calculus gives us the limit as b approaches infinity of, and now I have negative 1/2 e to the negative b plus 1/2 times 1, because e to the 0 was just 1. Well, now we're gonna go ahead and technically plug in infinity. We have e to the negative infinity, which becomes 0. So this now just becomes 0, meaning that we have a value of 1/2. Now, that is the improper integral. That's not what the summation is equal to, but because this converges, this series will also converge. So then we say converges through integral test, converges through integral test. Anyway, and that's gonna be it for today, guys. I hope you enjoyed 25 days of Mathmas. This was day 5, I believe. Get ready for day 6 tomorrow.